All right, today we're going to be taking some notes on box and whisker plots. So we're going to fill in some blanks and then label some vocabulary first. So the first blank, it says a box and whisker plot displays the distribution of data items along a number line. The next sentence, quartiles divide the data into 4 equal parts. The median is the middle quartile. Okay, so looking at this example of a box and whisker plot here, the lowest dot is for our least value, and then we have a whisker, so this long line here is called the whisker. Then the beginning of the box is where our lower quartile is, and sometimes we call that quartile 1 or Q1, so we're going to label that. Then the middle of the box here, this line that goes through the box, is the median, and sometimes we call that quartile 2. And then the last part of that box is the upper quartile, or sometimes quartile 3. And then on the other side, we have another whisker, and then our greatest value is going to be that last dot here, as far right as your box and whisker plot goes. So we are going to make one together here. So you can see that there's some data at the very bottom of your sheet. And it says that we are going to use the table shown to draw a box and whisker plot for Florida's number of wins. So even though this data here has both Boston and Florida's data here, we're only really caring about Florida. So what I'm going to do first is collect my data. So I'm going to write down all of those numbers for Florida, how many wins they had, and make a list of the numbers that I am working with. So I'm ignoring all of the Boston numbers right now. Now that I have my list of numbers, now I'm going to organize them from least to greatest. So I'm going to go ahead and pause my video, and I want you to do the same. Organize those numbers from least to greatest. All right, so now that we have all of our data in order from least to greatest, we are on to step 3. So step 3 says that we need to find the median. So I need to look at how many numbers there are in my data set. So I'm counting these up. It looks like I've got 12 data points. So since I have an even number, I'm going to put a line after 6 of the data points, so it's like it's cutting in half. And to find the median number, I need to take the average of those 2 numbers that I put the line in between. So my median is going to be the average of 79 and 79. Well, that's just going to be 79. So that one's an easy one to figure out for this set of data. So again, sometimes we call that median the second quartile or quartile 2. So just make sure that you know both of those vocab words for that. So then it says that I need to find the lower and the upper quartiles. So how we find those quartiles is that we are going to sort of find the median of both halves of the data. So I cut my data in half already. Now I'm going to find halfway on the first group. So that would be 3 on each side. So I have 54, 64, and 71 in that first quartile. So when I'm trying to find out what that lower quartile number is going to be, I have to take the average of those 2 numbers that it has to be in the middle of. So I'm going to add 71 plus 76 and then divide by 2. So 71 and 76 is 147. When I divide by 2, I get 73.5. So my lower quartile, or quartile 2, is 73.5. Now I need to do the exact same thing for the other half of the data. So again, I'm going to find the median on the right-hand side. That's going to be the upper quartile. So I need to, this time, find the average of 83 and 84. Well, halfway between 83 and 84, I need to add those together and then divide by 2, and I get 83.5. So our upper quartile, or quartile 3, is 83.5. All right, so now step 4, we are going to draw a number line that includes the least and greatest numbers in my data. So now that it's all in order, it's really easy from here. I'm seeing that my lowest number was 54 and my highest number was 91. Well, looking at the number, like the number of little dashes on my number line, I can't count by ones, but if I count by twos, I think I'll have enough space. So I'm going to start at that first tally and just start with 54, and then I'm going to count by twos going up. So I'm going to go ahead and pause the video while I finish doing this, and I want you to continue your number line, number the rest of it all the way up, counting by 2. All right, now that I have my number line all numbered out, I'm just going to mark these data points that I have found. So let's start with our lowest, our least value, that was 54. So right above the 54, I'm going to make a little dot, and even above that, I'm going to label it just to be extra clear on my box and whisker plot. So 54 was my least value, and my greatest value was 91. So that would be halfway between 90 and 92. All right, and now I'm going to make all of those numbers for the actual box of the box and whisker plot. So my quartile 1, let's start with that one, the lower quartile. That would be 73.5, so I'm going to make that dot. And again, this is kind of like why I like to write the numbers above, just to be extra clear if it's hard to see. My quartile 2, that median, was 79, so I'm going to find that and make a dot. And then my upper quartile was 83.5. And now I can take all of those pieces and put them together. So remember, we start out with a whisker, 2 whiskers on the outsides, and then there's a box, and then we make just a line for that median that kind of cuts that box, and then my last whisker. And there we have it. We have our first box and whisker plot. So let's go ahead and flip this over. We have just a couple of notes on the back that we want to fill in some blanks. So first off, interpreting box and whisker plots. So why do we make these math pictures? Well, it helps us to separate data into 4 parts, excluding outliers. Even though the parts may differ in length, each part contains 1/4 or 25% of the data. So when it asks, what does a long whisker or a box tell you? So if you see kind of how this example here is, even though all of those are kind of different lengths, they are the same percent of the data. Every single one is 25%. And if that's kind of hard to see on your paper, go ahead and fill that in. 25% of the data for every single section of the box and whisker plot. So if you have a really long whisker or a long part of the box, what that means is that your numbers or your data points are spread out. However, if you have a really short whisker or a box, that means that your data is very close together, or it may even be repeating those data points. All right. So looking at our 2 examples, we have number of chart hits, and this one, I just wanted to point out something on this one. We didn't talk about how to find outliers, but this little star that's way on the right of this box and whisker plot, that's how we would mark an outlier. So if you have one piece of data that's way far away from all the rest of them, that's going to be marked as an extra dot on your box and whisker plot. It's not going to be part of that whisker. So if you see an extra dot, that's an outlier. So for this one, it says what percent of the groups had at least 18 chart hits. So if I look on my box and whisker plot and find 18, that's that right there where I just marked. So if it's saying at least 18 chart hits, I'm looking for how many had more than 18. So if that 18 was halfway through my box, so that means that 50% of the groups had at least 18 chart hits. because 25% is in that top part of the box, and then that last whisker is also 25%. So there's 50% had at least 18 chart hits. Then it says, what does the length of the whiskers tell you about the data? Well, looking at the whiskers here, they're pretty short whiskers, so that means that my data was close together or repeated. So we can go ahead and write that in that question right there. So my data was close together for those whiskers. In example 2, we have 2 box and whisker plots, and so what's nice about this is that it's easy to compare those 2 sets of data without having to look at all of the numbers listed out. So this is for Olympic basketball players' heights in inches, and we have a box and whisker plot for the men and a box and whisker plot for the women. So it says, what conclusions can you draw about the heights of Olympic basketball players? So looking at these box and whisker plots, I'm noticing that the men's box and whisker plot is a lot higher of the numbers on my number line, whereas the women is kind of grouped down towards the lower numbers on the number line. So I could draw a conclusion that most of the men were taller than even the tallest woman basketball player. And I can tell that because the entire box for men and that last whisker are all above the highest woman's height, the greatest value for women. All right. So now we're going to get a chance to kind of try out making some box and whisker plots. So your steps are on the other side of your note sheet. Make sure you are referring to that if you get stuck.